We had force on a charge, Q V cross B. We'll recognize that V is just displacement over time. So Q delta X over delta T cross B. And this is the charge that is flowing, that is going by. So if I look at the charge over time, well, that's just current. So this is I delta X cross B, which is just current times whatever symbol I happen to be using for this. I have delta X here. This would be the same direction as the current flow. So direction of current flow, or positive charge flow, or opposite direction of negative charge flow. Oftentimes I think I just use L cross B. And so this is the force on a current flowing through. And if we had so if I have a current flowing in that direction and I have a external magnetic field that is coming out of the page, the direction that this wire is forced, well, again, I can do the right hand rule. Current is flowing that way, so I know it creates a magnetic field that's coming out on top and in on the bottom. So it's weakened down here, and so the wire should be forced in that direction. Or the current's going off to the right. If I set up an IJK, IJK, this is the direction of current flow, which is I hat. B is in the direction is in the K direction. And so I cross K is negative J. I cross K, negative J. Notice the implications of this. Suppose I have two wires, current flowing in the same direction. This is creating a magnetic field that affects that. We'll call that I1 and I2. This has a magnetic field that affects that. That has a magnetic field that affects this. Well, I know if the distance apart of them is, why don't we make that distance R? Then the magnetic field at this point, well, from I2 that's coming up, so this is the magnetic field from 2. It's going to be mu naught I over 2 pi I2 over 2 pi R. And this current is creating a magnetic field that is going down over here. So the magnetic field of 1 at this point is mu naught I1 over 2 pi R. I know that the force on this, the force on I1 from 2, is going to be current 1 times delta L cross B2. Now the length depends, it's actually physically the length. It does depend on the length. And so I'm just going to, first we'll deal with the cross product and then I'll bring L delta L over here. So this becomes I1 times L cross B. So up here, L is to the right. Let's set up our coordinate system here. I hat, J hat, K hat. And so that's the direction of the current. That's the I hat direction. B2 is coming out, so that's the K hat direction. I cross K is negative J. So this becomes I1, negative I1, delta L, B2, J hat, the negative J hat. Bringing the L over, I have F12 is equal to per length. And yeah, I know I have delta L here and L here. Hopefully you can get past that. Traditionally, it's written as L there. So the force per unit length on 1 is going to be equal to negative I1 B2 J hat. B2 is equal to that. So this becomes negative mu naught I1 I2 over 2 pi R J hat. And again, this negative J hat is just a directional thing. Now, if I want to know the force on 2, so the force on 2 from 1 is, well, we can go through the same logic there. But so that's I2 delta L cross B1. Now delta L is in the direction of current, so this is I hat. And I guess properly that should have a subscript there. I have I hat cross B1, which is going into the page, so that's negative K hat. So that is J hat. So this becomes I2 delta L to B1 J hat. So it is forced up, and that one is forced down. And so the force on 2 from 1 per unit length is equal to I2 B1. And B1 we know is that, so this becomes mu naught I1 I2 over 2 pi r. Oh, forgot my J hat there, J hat. Notice that the magnitudes are the same, and they better be. If they're not, then we have some issues here. Why do the magnitudes have to be the same? This is the force on 1 from 2. This is the force on 2 from 1. Newton's third law. If wire 2 exerts a force on wire 1, then wire 1 has to exert a force on wire 2 of the same magnitude but opposite directions. And that is indeed what we have right here. Newton's third law holds true, as it should. There are some eccentric cases, because once we sort of realize that how does one object know another object exists, it does take time for the signal to get from one place to another. And so there are situations, depending upon how they're traveling, but they are bizarre and extreme, and that's the stuff that theorists deal with. So we have the force per unit length of 2 wires, U1, I1, I2, over 2 pi times the distance between them. This obviously is just magnitudes. You can figure out directions using right-hand rules, or in some cases I've seen pure luck.